We use a lot of paper. In fact, paper is one of the most common materials we encounter in our daily lives. From the moment we wake up and read the morning newspaper, to the packages we receive in the mail, paper is everywhere. It's in our books, our notebooks, our receipts, and even in the tissues we use. The sheer volume of paper we consume is staggering. Think about all the books, cardboard boxes, and newspapers we use every day. It's a huge amount. Every year, millions of tons of paper are produced and used worldwide. This paper serves many purposes, from packaging our goods to providing us with information and entertainment. However, the life cycle of paper doesn't end when we are done using it. And you know what happens to most of it? It ends up in landfills. Despite efforts to recycle, a significant portion of paper waste still finds its way to these massive waste disposal sites. Once there, it becomes part of a growing problem that affects our environment in numerous ways. That's a big problem for our planet. Landfills are not just eyesores, they are environmental hazards. The accumulation of paper waste in these sites contributes to a host of issues, from soil and water contamination to the emission of harmful gases. Paper waste takes up space in landfills, and these landfills are already overflowing. As our consumption of paper continues to grow, so does the pressure on these waste management systems. The space available for waste is finite, and we are rapidly running out of it. When paper decomposes in landfills, it releases methane, a harmful greenhouse gas. Methane is significantly more potent than carbon dioxide in terms of its impact on global warming. This means that the paper waste we discard is not just taking up space, it's actively contributing to climate change. We need to find a better way to deal with all this paper waste. Recycling is one option, but it's not always efficient or feasible. The process of recycling paper can be resource-intensive, and not all types of paper are recyclable. We need innovative solutions that can address the root of the problem. What if we could turn this problem into a solution? Imagine if the paper waste that clogs our landfills could be repurposed into something useful, something that could benefit society and the environment. What if we could transform paper waste into something valuable? This idea isn't just a dream. It's becoming a reality thanks to groundbreaking research and technological advancements. Well, get ready for some exciting news. Scientists have been working tirelessly to find ways to repurpose paper waste, and their efforts are starting to pay off in incredible ways. Scientists have developed a revolutionary technology that can turn paper waste into zinc-based batteries. This innovation is not just a theoretical concept, it's a practical solution that has the potential to revolutionize both waste management and energy storage. Yes, you heard that right. The paper waste that once filled our landfills can now be transformed into a valuable resource that powers our devices. We can now use paper to power our devices. This breakthrough means that the paper waste we generate can be converted into energy storage solutions, reducing our reliance on traditional batteries and decreasing the environmental impact of both paper waste and battery production. This is a game changer for both waste management and renewable energy. By turning paper waste into zinc-based batteries, we can address two major environmental issues at once: the problem of overflowing landfills and the need for sustainable energy solutions. Let's dive into the science behind this amazing breakthrough. The process involves breaking down the paper waste into its basic components and then reassembling those components into a form that can be used in battery production. This innovative approach not only reduces waste, but also creates a new, sustainable source of energy. The potential applications of this technology are vast, from powering small electronic devices to providing energy storage for renewable energy systems. As we continue to develop and refine this technology, we move closer to a future where our waste is not just a problem to be managed, but a resource to be harnessed. So, how do we go from paper waste to a battery? It all starts with a key ingredient found in the cell walls of plants, lignin. Lignin is a polymer that gives plants their rigidity and strength. It's what makes trees stand tall and gives wood its sturdiness. The first step is to extract lignin from the paper waste. This is done through a process called delignification. Once we have the lignin, it undergoes a series of chemical reactions. These reactions transform the lignin into a porous carbon structure. This structure is perfect for making electrodes, which are essential components of a battery. These lignin-based electrodes are then combined with zinc, another readily available and sustainable material. Zinc is used to create the anode, the negative electrode of the battery. When combined, these components create a zinc-lignin battery. Lignin is the second most abundant natural polymer on Earth, after cellulose. It's a complex polymer that's been largely underutilized. We mostly use it for paper production, but even then, a significant portion ends up as waste. But lignin has hidden potential. It possesses remarkable electrochemical properties, making it ideal for energy storage applications. Its porous structure provides a large surface area for chemical reactions to occur. This means it can store more energy, and because it's derived from renewable plant material, it's a sustainable alternative to traditional battery materials. Section 4: Zinc, a sustainable alternative for energy storage. Let's talk about zinc. Zinc is an abundant element found in the Earth's crust. This makes it a readily available and cost-effective material for batteries. Unlike lithium, which is often used in rechargeable batteries, zinc is safer and more environmentally friendly. Zinc batteries have a long history, dating back to the 19th century. However, they fell out of favor due to limitations in their rechargeability. But recent advancements in battery technology have overcome these challenges. We can now create zinc-based batteries that are rechargeable, efficient, and long-lasting. Section 5: Powering our world applications of zinc-lignin batteries. Now let's talk about the potential applications of these amazing batteries. Zinc-lignin batteries are incredibly versatile. They can be used in a wide range of applications, from small electronic devices to large-scale energy storage systems. Imagine powering your smartphone or laptop with a battery made from recycled paper. That's the future that zinc-lignin batteries offer. They can also be used in wearable electronics, medical devices, and even electric vehicles. On a larger scale, they hold promise for grid-scale energy storage, helping to make renewable energy sources like solar and wind power more reliable and efficient. Section 6: A greener future, the environmental impact. The environmental impact of this technology is significant. By diverting paper waste from landfills, we reduce methane emissions and conserve valuable landfill space. And because zinc and lignin are naturally occurring materials, these batteries are biodegradable and non-toxic. This means they don't pose a threat to human health or the environment when disposed of properly. By using renewable materials and reducing waste, zinc-lignin batteries offer a more sustainable and eco-friendly alternative to traditional batteries, which often rely on harmful chemicals and heavy metals. Section 7: Challenges and opportunities for zinc-lignin batteries. While the future of zinc-lignin batteries is bright, there are still challenges to overcome. One challenge is scaling up production to meet the growing demand for energy storage solutions. Further research and development are needed to optimize battery performance and longevity. However, the opportunities presented by this technology are immense. The global demand for batteries is skyrocketing, driven by the growth of the electric vehicle market and the increasing need for renewable energy storage.